Ladies and gentlemen, welcome to our ERCI STARS webinar on innovations enabling condition-based monitoring and maintenance. My name is Lutz Hübner from the Cluster Transport Mobility and Logistics in Berlin and Brandenburg, and part of the European Railway Clusters Initiative. This is a webinar which is jointly organized by ERCI and the EU project STARS. And first, I want to tell you something about ERCI. It's the European Railway Clusters Initiative, founded in 2010. And now, in this year, we took the second step to be a legal entity based in Brussels. We are 15 railway clusters covering 60 European countries, including United Kingdom and Sweden in the north, and the former Yugoslavian republics and Turkey in the southeast. And for sure, other countries are covered by the ERCI. We are covering over 2,000 companies, of which are the majority small, medium-sized enterprises, and for sure also covering the science, universities, research organization, education institutions, incubators, accelerators. Yeah, our services is at first bringing support for small, medium-sized enterprises in their market development inside the country and or outside their country, inside EU and also outside EU. Visibility on European level, a second task. Also to give especially SMEs the chance to be partner in European research and development projects, for instance, in Horizon Europe and in Europe's Rail. We have innovation topics to elaborate, and these are innovation topics from which we are thinking about that they have some major influence on the future development of the rail system. It's on cybersecurity, on multimodal logistics, on green and sustainable mobility, on norming and standardization, and also on human factors. And we have one instrument to deal with these topics. It is the ERCI task forces, which have for sure also the aim to have a good network of competencies on European level, and for sure the task forces will also be used in development of new projects. Then we have bilateral workshops and webinars in order to. I kindly ask you to mute your micro, Goraz. We have webinars in order to introduce especially small, medium-sized enterprises with their innovative products, like the current webinar on condition-based monitoring and predictive maintenance. And one yearly highlight, annual highlight are the ERCI Innovation Awards. You will find some more information on ERCI at our website, on Twitter and LinkedIn. Then we are also engaged, or some of the partners of ERCI are engaged in the STARS project. And it's on strategic alliances boosting railway SMEs, giving support to successfully adopting advanced technologies to boost products, services, manufacturing processes, and organization of small and medium-sized enterprises. The first question is, how digital mature are European SMEs in order to apply advanced technologies in their processes? And to give a picture on this, the STARS project launched a survey which can be found by following the QR code or by following the project webpage. And if you are a small, medium-sized enterprise and are interested to get some support from the STARS project, some business support and some technological support in order to adopt advanced technologies, you are invited to take part in this survey. And within this project, some innovation trends have been detected and elaborated, and innovation trends which will have a major influence on the rail sector until 2030. And the core question is how to tackle these innovation trends with the help of advanced technologies, and especially by small and medium-sized enterprises. And you will see here on the cloud some keywords which are representing these advanced technologies we are dealing within this project. For instance, blockchain, virtual reality, augmented reality, security, connectivity, robotics, and so on. The approach of the STARS project is to give the small, medium-sized enterprises which take part in this project free of charge business support and technology support. And it would be the best situation that the small, medium-sized enterprises are members of one of these cluster organizations which take part in the STARS project, but also other SMEs are welcome. Then, based on the results of this survey, the small and medium-sized enterprises will be grouped into so-called strategic alliances. These are these bubbles here, 10 to 11 SMEs from at minimum 3 European regions will discuss together with technology centers, which are also part of the project, and for sure also with the other SMEs on their major pain points in adopting advanced technologies, and they will get some technical assistance also by the technology centers, and maybe also with the help of the so-called hack and match events. This is the step where the traditional small, medium-sized enterprises will get in contact with tech-savvy enterprises. These are SMEs or startups which have good competence, good knowledge in one or more advanced technologies. Maybe they have less competencies in the railway sector. So in the end, it could be a win-win situation, both for the traditional small, medium-sized enterprises and for the tech-savvy small, medium-sized enterprises in adopting advanced technologies on the one hand, and to get better knowledge of the railway sector on the other hand. So first, STARS Hack and Match event is still ongoing. It's on energy efficiency, but the future for Hack and Match events which will take place until the end of September next year within the STARS project will have some other challenges elaborated by one of the strategic alliances.
Nisti zančno štelo, da film mi na tisti blok ne deluje. Zančno nastavite šo.
So you have also the possibility to get in contact with other participants, with tech-savvy SMEs and other service providers by using the STARS Hack and Match events platform. And these events platform is a B2B matchmaking platform to be used by the Enterprise Europe network, also to several B2B matchmaking events. And you have the possibility to use also this platform to install a small profile of you and your company, maybe also to define what services and products you are going to present. And then you have the chance to get in contact with other participants of the platform. The links will be set up in the chat during the first presentation, as well will be visible after the webinar when I will send all the presentations to the participants of this webinar. So, yeah, who should take part in the Hack and Match events? Not only small, medium-sized enterprises, also academia, also large industries and stakeholders of the railway and multimodality sector. And there is some benefit to take part in the Hack and Match events. You can publish and showcase your products. You can initiate and arrange promising pre-scheduled one-to-one B2B meetings. You could generate fresh leads and meet new contacts, and maybe you can stay one step ahead of your competitors. So I think lots of information regarding the STARS project, and I will now hand over to the first presentation, and it will done by Francesco Lombardo. He is a strategic commercial projects manager in the railway division of Lucchini, a technology provider from Italy and member of DITECFER, and by his colleague Stephen Cavello, innovation and design manager, also in the railway division. The floor is yours. Please open your micro.
Okay, can you hear us?
Yes, perfect.
Okay. So good morning to everyone. And I'm Francesco Lombardo, and I'm product manager of Smartset, the innovating solution from Lucchini RS for the CBM of wheelsets. So I will give you a brief introduction of the product. Just remain a little bit general and introducing just the main concept. And then my colleague Stephen Cervello will go a little bit into technical detail of this solution. Okay, as mentioned before, we are in the, let's say, in the field of condition-based maintenance. Especially in the last times, even more product and solutions are coming to the market on this, let's say, sector of maintenance. It's a sector which is based on objects which are reading data and collecting data and giving them information. Obviously, all those data are used to enable predictive strategies for maintenance, and obviously CBM is one of these possible strategies. Just to give a let's say, a definition of condition-based maintenance. CBM means that inspection of vehicle or part of vehicles have to be performed not on, let's say, prefixed schedule, but thanks to those data and information coming from them, stops and maintenance operations should be performed on the actual history of the service conditions of the vehicle. So this is the change of the, let's say, paradigm into the maintenance. If we move to, let's say, trains and wheelsets in particular, obviously we know that wheelsets are a critical components in terms of safety. For a vehicle, railway vehicle, we are running at more than 300 kilometers per hour rolling on those components. So generally, a lot of attention is put into maintenance and in operations of those components. And since today, the inspection intervals of wheelsets are generally not related to real service condition of the vehicles, but they are generally coming from experience or let's say prefixed intervals which are coming from adopted for the entire platforms, generally for trains which are running on different tracks, different country, in different conditions, but in any case, based on prefixed schedule, not related then to the, for instance, real condition of the network or, for instance, the payloads, which may vary country from country, service to service. And obviously, this introduce inefficiencies in the maintenance schedule, and it's a major source of cost for operators which are doing maintenance, or also for the operating company, because obviously trains should be put off from the service, and this means obviously missing revenue. At the base of these problems, the fact that so far there is no scientific tools which could, let's say, define an optimized maintenance period based on the real service of the vehicle. And here comes Smartset. We want to say a Smartset revolution because it's just a revolution in this field. Smartset is a intelligent tool which is mounted directly on the wheelsets and is able to measure loads in operation and giving back data which can be then used for the optimization of maintenance of the wheelsets. In few words, we are collecting load history, and then we are able to elaborate those data for simulating the crack propagation of an hypothetic defects on the axles, and then estimate the correct non-destructive test intervals of the wheelsets. So you may immediately understand that it's an easy and a practical way to optimize the inspection frequency, especially for non-destructive tests, and then maximizing in this way the availability of the vehicle for the service. So in some way, we are just squeezing the as much value as we can from the wheelset, optimizing the maintenance, but at the same time keeping the safety level to the highest possible level, basically. So this is why we want to create a motto, value in safety, for this product. As any product that is producing data from the service. This is not the only feedback that you can achieve from a product like Smartset. So once you have data in your hands, you may use also those data also for other scope. And for instance, you can use these data to validate the design of the vehicle, of the body, because basically we are measuring, analyzing loads. So this means also the possibility to check the design of the vehicle, or maybe in a second stage of the design also to optimize the design of the bogie, or of the, for instance, suspension systems, etc., from the bogie. Another interesting feature is the possibility to characterize, for instance, the impact of the vehicle on the network, and vice versa, because in any case, loads on wheelsets is always coming from the interaction between the wheelset and the track. And another interesting feature is the possibility to identify along the network some hotspots, we call hotspots, where we have the higher loads during the running of the train. And by monitoring those hotspots, so those peaks in the loads, also we are able to identify, for instance, if there is any degradation or deterioration of the networks along the time, during the time. And obviously, for instance, giving then feedback to the infrastructure manager and to say the possibility to inform them that something's getting wrong on the network. So, as you say, that a product which was basically developed from one scope, which was mainly the optimization of the maintenance of the wheelsets, but as any IoT object which is providing data, then other possibilities were opened once that you have data in your hands. I will now leave the stage to Stephen, which is giving you a brief description of the technology behind Smartset.
So good morning to everybody. We can say that a Smartset is basically made of two elements. The first one is the intelligent sensor, which is embedded on the axle surface, which is measuring continuously the stresses on the axle and processing them in real time, providing to the cloud the load spectra of these stresses. The second part of Smartset is then the crack propagation algorithm, which is a software that we have developed with the collaboration of Polytechnic of Milano in the last 20 years. We call it Star Crack, and it's the software that we use to calculate how many kilometers it will take for a crack, a small crack, to propagate in the axle, based on the real stresses that Smartset is collecting during the time. And based on this, we can then finalize and define the best inspection intervals to be used when we inspect axles with ultrasound probes. This way, we are able to optimize the maintenance plan of the vehicle.
Stephen, you are mute.
Sorry, you didn't hear anything of what I said?
Not from this slide. Start again this slide, please. Thank you.
Strange. Okay, I was just saying that the Smartset is made of a telemetry module, which is installed directly on the axle, measuring continuously stresses on the axle and processing them according to a specific algorithm. The data which is collected on the telemetry is then delivered to a small computer, which is installed under the car body. And from there is then sent to the cloud in order to be able to be visualized and used in the calculation of the crack propagation. We will see also how the telemetry module is power supplied by this electromagnetic inductive solution. Here we have a close view of the telemetry. It's a flexible PCB board applied directly on the axle and is measuring 2 strain gauge channels in the frequency band of 0 to 500 Hz. So it's able to collect also high dynamic loads acting on the wheel set. Here you have an idea of what the installation looks like. So it's a permanent installation. We have wheel sets which are in service for more than 3 and 4 years, and they're still working. And as you can see, all the system is completely covered and protected by a special resin, and then the axle is painted as usual. We come now to the algorithm which is running on the telemetry board. So it's the well-known rainflow algorithm, which is used a lot in fatigue analysis. And basically, you can imagine that on the axle, we have a sinusoidal kind of signal representing the stresses while the wheel set is rotating. This algorithm will be able to identify each load cycle in this signal, and from each cycle, it will identify the main value and the amplitude of the value. And these cycles are then counted in this matrix that you see in this picture on the right. And on this axis, on the right axis here, we have the stress amplitude of the strain gauges. On the other axis, on the left side, we have the main value. On the vertical axis, we have the number of cycles. When we consider only the amplitude, summing together all the values for each level of amplitude, we can get this kind of diagram that you see on the bottom right side. And this is basically the amplitude of the stress cycles versus the cycles. We can immediately see the most frequent loading condition acting on the wheel set that we know is corresponding to the straight running condition. And basically, it's corresponding also to the wheel set static load condition acting on the wheel set, of course. And the higher loads happen when the wheel set is running in curve, or also when it's running over switches or irregularities that generate an increase of load. Of course, depending on the direction of the curve, these stresses will increase or decrease, considering the position of the strain gauge on the axle. One thing that is possible to do is to define a number of main stations, railway stations, where the train will be running through. And if this is done in the software which is running on the computer, which is installed under the car body, the system will be able to differentiate load spectra per each track section. For instance, if I am in Milano, position A, I will be downloading at that point the matrices from the telemetry module, stored in the memory. When I will arrive in Bologna, position B, I will download again these rainflow matrices. And if I subtract the last matrix with the previous matrix, I can obtain a matrix corresponding to the track section going from A to B. And this enables us to differentiate the load spectra per track sections. Of course, then we would normally look at the complete load spectra in order to use this data in the crack propagation calculation. But this is an option that I explained to be able to compare the load spectra of different track sections along the network. If we are interested in knowing what's happening along the track, and for instance, where are the high loads appearing during the journey of the vehicle, we have developed a specific algorithm which is running also on the telemetry module, in which we can define a threshold on the stress amplitude, and every time the threshold is exceeded by the signal, the algorithm will identify the maximum value reached before going down below the threshold. And this value will be saved in the memory of the telemetry together with the time reference position. And after that, this value of stress will be correlated to the geographical position that has been recorded by the computer from the GPS antenna. And this enables us to identify the positions along the track where the high loads appear. And by experience, we can see that these high loads appear along narrow curves, but also in correspondence of switches and crossings. And by monitoring these high values of stress during the time, there is the possibility to identify positions where these high loads are starting to increase due to some kind of deterioration of the track. And potentially this gives a great input to the track maintenance operator, who can be advised of the positions which need to be inspected due to some changes that have happened during the last period of time. This is also an option which is not related to what was the main scope of Smartset, which is to optimize the inspection intervals of the wheelsets. Going back to the installation, here you have an idea of what is necessary to power supply the telemetry module. It's a device which is installed in the case of a motor wheelset directly on the gearbox by using some of the screws which are present on the gearbox. Or in the case of a trailer wheelset, we needed to construct a simple beam which can be fixed to the structure of the bogie frame. This device is power supplied by DC voltage, 24 volt, and it's generating near the axle electromagnetic field, alternated electromagnetic field. And on the axle, we make a special coil, very thin, made of copper, connected directly to the telemetry module. And by induction, we will generate electricity, which enables the power supply of the telemetry module. So this means that every time we have DC voltage arriving to this device, the telemetry will be working, measuring, and processing the data measured by the strain gauges. In the case of freight cars, we have been also using some special electric generator, which is installed directly in the axle box of the wheelset. As I said before, there is a small computer installed under the car body, which has the function of collecting the data from the telemetry module through a Zigbee radio connection, and to supply it to the cloud through a GSM connection. This antenna is also including a GPS antenna, so that it is possible to upload from the telemetry the matrices, also at specific geographic positions. In these two pictures on the right side, you see an example of installation of the computer box and of the antenna, which needs to be on the side due to the presence of the GPS antenna. We come now to the crack propagation software. It's a software, as I said, developed with the help of our friends in Polytechnic of Milano. It's been developed in the past 20 years based on many full-scale experimental tests brought over on the test rigs like the ones you see in this picture on the right side. The model is based on the NASGRO crack propagation model, which is been used for a long time in the aerospace sector. The star crack software basically is providing us the propagation curve, and from there we can define the inspection interval with a low probability of failure. In these two pictures on the left side, we can see an example of crack propagation curve. And on the top side, an example of POD curves. POD stands for probability of detection. That is the probability that the UT device is able to see a crack depending on its dimension. Here we see in particular the crack depth. Of course, bigger the crack, higher is the probability. And while the crack is propagating, this probability will increase, of course. If we consider the probability of non-detection of each time that we make the inspection and we multiply together these values, we obtain the probability of failure intended as the probability of not being able to see this crack in the axle with the equipment that we are using. So basically, this is the way we define the interval in order to have this probability of failure sufficiently low. So finally, the inputs to the software are material data coming from crack propagation tests made during the years on the different steel grades that we use for axles. The load data coming from Smartset, and then the POD curves that we have developed for some of UT devices that are normally used on wheelsets. The data that we collect is directly available to the customer because it's considered of his property, and it can be downloaded by the customer through a portal that we have developed based on SAP Leonardo. And here the customer will be also able to see the results of the crack propagation calculations and all the data that has been used in this kind of calculations. In these following slides, I will show you an example of application. It's actually the first pilot project that was made together with Trenitalia some years ago, and it was based on instrumentation of a Loco E464 wheelset. It's a Loco produced by Bombardier and used very common in Italy and used for regional passenger service. There are 700 units running in Italy starting from year 2000. They have been accumulating a high number of kilometers altogether, and the probability of the inspection interval fixed at 320 kilometers at 300,000 kilometers was confirmed to be positive by the return of experience. The wish of Trenitalia was to understand the possibility of adapting this interval depending on the region where the train was running. Here we see the track, the lines where the train was running in the first year. It was the center of Italy, and we identify 3 of them depending on its characteristics. So the orange one, the Adriatic line, is relatively straight, whereas the other ones have more curves. In particular, the green one was considered to be a line with a high density of narrow curves and so more severe for the loads. Looking at all the data collected, here we see on the left side the bending stress load spectra acquired at different mileage positions, and the last one on the right side is relative to 130,000 kilometers. That's almost 1 year of service. And what we can see here is that the maximum load in the load spectra was increasing during the first period and then tending to stabilize. This is quite expected, I would say, because we know that the longer is the period of measurement, the higher is the probability of measuring extreme condition. But finally, this high load has to stabilize at one point. It will not grow forever. That means that it's very important to be able to measure data on a long period and not only for 1 week, for instance. On the right side, we have instead the diagram for the torsional stresses, which are also of interest in order to identify if there are high loads from torsion that could be related to torsion oscillation, which is a stable phenomenon that can happen on motor wheel sets. Another thing to be observed is that in the bending load spectra, the most frequent load level remains constant during the time, meaning that the measuring system is very stable. When we compare the load spectra from the different track sections that are identified on the left picture, we see that there is in particular the green one, which has a higher number of cycles in the upper range of the loads levels, meaning that this spectrum is more severe. Consider that the cycles here in this axis are in a logarithmic scale, so this small difference that you see here is actually quite large. When we use these load spectra and calculate the crack propagation, we can make a comparison on the distance that the crack takes to propagate, depending on the different load spectra that we have measured. And if we normalize to the one with the green one, we can see that on the straighter line of the Adriatic coast, the propagation time is almost 2.5 times longer, meaning that depending on the load spectra, and that means depending on the service condition, the inspection interval can vary. The optimal inspection interval can vary quite a lot, and this shows how it can make really sense to use this kind of device in order to fix correctly the inspection interval. I will say a few things about the reliability of the Smartset system. So first of all, we are using strain gauges, so it means that we are applying well-known standard procedures for the installation and for the calibration. And here there is our reference for the calibration of the measuring system. This calibration can also be verified after the installation under the train by using a device to measure the load between the wheel and the rail and to correlate this load to what we are measuring in that moment with the strain gauges. In order to be sure that the system is stable during the time, we look at the most frequent loading condition that has to remain statistically constant during time. To verify that the algorithm is counting correctly the cycles, we can sum together all the cycles of the load spectra, and from there we can estimate the mileage that the wheelset has run from the beginning of the measurement. And we have found that this counting method is very near to the real mileage of the vehicle. In our installations, due to the fact that the measurements that we are doing are very important and critical for the safety, we normally install the system in redundancy. So we have two telemetries actually on the axle, measuring strain gauges in the same section, so that we can compare measurements of one telemetry with the other one. And the variation we have found is very low, is less than 0.1%. And this also tells us that the system is robust. Then there is an automatic system in order to check the fact that data transmitted through the radio connections remains correct and not corrupted. In that case, the data can be sent at another time and corrected. We have wheelsets that have run a lot of kilometers, and particularly on high speed, we have already went beyond 900,000 kilometers, and the system is still working perfectly. The system is also fully compliant with the requirements for electronic equipment to be installed on railway vehicles. and we have, let's say, qualified the system according to this European directive, which is including all the requirements for the authorization for the service of a new vehicle. And in particularly, we have these standards that have been followed in the certification of the system. The most important of them is the electromagnetic compatibility, for which we have proved the fact that the system emission is not affecting the other systems, in the sense that the emissions of the Smartset system is below the limits defined in this standard. We have also verified the immunity of the Smartset system to the electromagnetic and disturbances that we can have on a railway vehicle. So we can sum up and come to the conclusions. We can say that Smartset is a practical way to reduce the NDT inspection frequency to the actual need. In this way, we can reduce cost, reduce the number of train stops, and that means increase the vehicle service availability. We have proved during these last years the high reliability of the Smartset system. As I explained just now, we have wheelsets that have served more than 4 years and have gone beyond 900,000 kilometers. I've shown some results of the first pilot project that was brought over together with Trenitalia on the E464 locomotive, demonstrating how the inspection interval can vary quite a lot depending on the condition of the lines on which the train is running. Moreover, Smartset can be used also to validate the vehicle bogie design, knowing the real load spectra on the wheelset. And this, of course, is of great interest for the vehicle manufacturers. I've showed how with Smartset we can also look at the track and identify hotspots along the line where the high loads take place, and to monitor them during the time, enhancing track maintenance strategies. Smartset could then also be a basis for track access charges evaluation, knowing the interaction that we have between the vehicle and the track. Finally, we can conclude saying that Smartset increases the service competitiveness by creating value in safety. So here we have some pictures of some of the vehicles on which Smartset is running today, and I can mention here that we were awarded a couple of years ago by DITECFER ERCI as a railway innovation leader in 2020. And also we got an award from SAP for the development of the portal that was brought over a couple of years ago. Okay, I would like to thank you everybody for your attention, and if you have any questions, please, we are available.
You are mute, Lutz.
So better. Thank you, Guido. Interesting presentation, many questions. Thank you very much for the interesting presentation. And you can see in the slide there are many questions, and the first is on the number of intelligent sensors could be mounted under a train.
Under one train. Well,
yeah.
I didn't speak about this actually, but it's an important question, this, because you don't really need to install Smartset on each wheelset of the train, because what we say is that we normally would mount a Smartset on the first wheelset of the train set, and we would say that the data collected by this wheelset is representative in a conservative way of the loads acting on the other wheelsets, because on the first wheelset we normally have higher loads as this is the leading one. But of course, there may be situation in which other wheelsets along the train have a higher axle load or have a different design from the first one. And so normally there could be one or two wheelsets to be instrumented on a train set. Then if we look at the complete fleet of trains, and if these trains are running on the train on the same network, you could also think that the data collected by these wheelset installed on that train can be representative also of the other trains. So in conclusion, we can say that if for a fleet of trains, it could be sufficient to install one or two of these wheelsets, considering what I said, that the data that you collect is representative of all the others.
The second question, can the Smartset mount it only on the existing trains or also on new ones?
Yeah, we developed Smartset in order to be easily mounted on existing trains. Of course, we need to have the wheelset in our laboratory or in any place where we can work for the instrumentation. So that means that the wheelset needs to be dismounted from the train to make the installation, but we don't need to make any modification to the wheelset itself in terms of structural modification, I mean. This means that it's very easy to install Smartset on an existing train. But it can also be installed on new trains from the beginning without any problem.
Is it possible to measure the imbalance in terms of percentage of the right side from the left side of the wheelset? The idea is to measure the load on a freight wagon.
Yes, we have, for instance, freight wheelsets in service with strain gauges on left and right side. That means that we are collecting load spectra for both sides. So that is possible. Maybe the question here is more related to the fact that for one journey, I'm able to understand if there is an imbalance. So potentially yes, because during the journey, I can verify the loads and see if there is a difference. So potentially yes, I would answer yes to this question.
Which is the technology used for the energy production of the module inside the gearbox? Was it used for vibrations?
Okay, and it's not inside the gearbox, it is installed outside by using some of the screws that are normally present on the gearbox. So on these screws, we mount a metal support, which is supporting this in what we call inductive head. Is this device that is generating an alternated electromagnetic field near to the axle body. And on the axle, we have installed a copper coil around the circumference of the axle. And by electromagnetic induction, we generate alternated voltage.
But the module is taking power from the power of the train, so it's not generating.
The power, the original power is coming from the train, from the battery of the train. It's a DC voltage of 24 volt.
So the module is just transforming normal power into an electromagnetic field. It's not producing power itself.
Yes, exactly.
Yeah, for what concern wheelset maintenance, it is correct to consider Smartset capable of optimizing and avoiding the ultrasonic testing task on the axle. That needs from time or kilometer-based maintenance to condition-based maintenance.
Correct to consider Smartset capable of well, this is the main purpose of Smartset.
Yeah.
It is possible to optimize. Normally optimize means in this case to increase the interval, because inspection intervals are defined very conservatively normally. And so the result normally is that it is possible to increase these intervals. And in some cases, it could be that ultrasonic inspection could be avoided. Could be avoided. Depends on the design of the axle. Depends on the condition of the line. But this is also potentially possible.
Yeah. Apart from continuous monitoring and thus increased safety, is there any other maintenance on wheelset that could be improved with Smartset?
On the wheelset.
You can consider that obviously wheelset is not just made of the axle and the wheels, and generally we also say that Smartset is an enabler for the optimization of a maintenance of the other components of the wheelset. So generally the maintenance schedule of the wheelset is a sort of collecting all the maintenance schedule, for instance, of gearbox, axle box, brake disc, bearings, especially, etc. So the idea but obviously the most tight is generally the NDT schedule. So the idea to give customers the possibility to extend the NDT inspections intervals, for instance, could enable the fact that you may also optimize and postpone also the maintenance of other components, for instance, like bearings. So generally, you have to check the bearings because in any case, you are generally doing or performing maintenance of a lot of components because in any case, the train is stopped and so obviously you may not want to stop again the trains after 10,000 kilometers to check bearings, for instance, once that the train is stopped. So the idea is that thanks to Smartset, so giving the possibility to extend the maintenance of the axles, give also the possibility to extend the maintenance of other components. So from this point of view, Smartset is an enabler for the optimization of maintenance of also other components.
So 3 last questions. Where are exactly the cracks that you estimate propagation of in the axle and the wheel? Can you also identify other kinds of defects in the wheels like flat spots or changes in conductivity?
So as I said at the beginning, this Smartset will not be installed on every wheelset. So it's a device in order to collect information about the loads that all the wheelset of the fleet are having during the service. And we will use these loads in order to see how a crack propagates in the axle.
An hypothetic
crack, of course. We're not speaking of a real crack that we see on that wheelset. And so we are focusing on the axle because the axle is the component which is more often inspected on the wheelset by ultrasound inspection. Other defects that can generate on the wheels, as is explained here, of course, if they generate on this wheelset, which is instrumented, we will measure the effect on the loads of these defects. But this doesn't mean that we are able with Smartset to find these defects on all the wheelset of the train set. This is clear. For that, you need to have other kind of devices.
So 2 questions left. Have you considered the possibility of recording data provided by Smartset on blockchain?
Blockchain.
Not yet, actually.
No. It could be a possibility for the future, but good to consider for the future, yes.
Yeah. How do you account for sensor degradation in your POD calculations? Last question.
I don't know here with sensor degradation what is meant. If it's the sensor of Smartset.
No, I don't think so.
Or the sensor of the ultrasound inspection.
Sure.
Yeah, could you, Vamsi, ask this question, maybe he or she can open the micro and ask directly.
I think it's about the ultrasound.
Yes, yes. I mean, the sensors what you installed onto the axle. So there could be chances that these sensors might also get degraded upon service. So how do you account for sensor degradation while collecting the data?
Well, in this presentation, there was a slide about how we verify, let's say, the reliability of the system, and there are different measures, as I explained. First of all, we are checking that the most frequent load, which is that we can find in the load spectra, is remaining constant, because this is directly related to the static load of the wheelset. Remaining constant during the time, of course. If this static load would start to increase, to deviate, as it may happen when you have a problem on the measuring, it would mean that this sensor is not reliable anymore. But that's not the case for the wheelset we have in service up to now. We cannot, as I said, also the telemetry modules are installed redundantly, so we have two separate systems measuring the same data, and we can compare that the two are measuring the same. And we did this because of course it's important to prove that the data that we are collecting is correct. So finally, it's important to measure for a long time, but normally we say that 1 year is enough 1 year of measurement is enough to provide to the customer the first calculation of the inspection interval. Then we expect that this should not change afterwards, but the Smartset wheelset can remain installed on the train for many other years, let's say, in order to check that everything remains as we found during the first year. But of course, if the system is not working anymore, we would realize this.
So thank you very much for all of your questions, and I'm very sure that you will have additional ones, and I'm also very sure that all the presenters will provide their email addresses in order to give you the chance to set more questions. So let's come to the second presentation.
Thank you.
It's on how these next generation rail technologies company assists railways by using innovative technologies. Richard is CEO and chairman of NGRT, and this is a member of one of our Spanish partner clusters, MAFEX. And Richard, the floor is yours.
Thank you very much, Lutz. I trust that you and the rest can hear me well.
Yeah.
Yeah, I'll share my screen then. So let's see.
Oh, this reference. Yeah, that's better. Good.
Now you have this in slide mode, yes? Okay. Well, thank you again, Lutz, for organizing these highly interesting webinars and addressing important topics. Today I'm going to talk about how not only NGRT can assist the railways, but a little bit also the challenges that the railway infrastructure managers are facing when it comes to their infrastructure. Game-changing technologies, game-changing moments. Our clients are actually calling NGRT their game changer when it comes to providing them information about their infrastructure. And one of the biggest, let's say, changes is the cost, which we can come back to a little bit later on. Our mission is to use new technology, novel technology in somewhat based on old-fashioned principles to improve the safety and also increase the network capacity, and, as I said, to a significantly lower cost. If we look at the infrastructure, let's say, conditions, taking into the account the what everybody now is talking about, the climate change and conditions changes and so on, that has obviously an impact on the railway infrastructure. It's very difficult to move a railway line from areas which now can be exposed for changing weather conditions. So it's all about how can you protect that and how can you predict something that might happen before they have catastrophic consequences. A small, tiny mudslide seen on the top left picture can in fact cause a significant derail, as it did with the SNCF high-speed train, which led to, unfortunately, 3 casualties. So there are various consequences based on this. So it's all about keeping the focus, and when you mix rolling stock and trains with softer traffic and also humans or animals, if for that sake, it's always the rolling stock and the trains that wins the battle. So how can we and what have we done to help? First of all, we have built our own technology, both hardware and software, all of which is built according to SEAL specifications, as the previous presentators mentioned. It is very important to follow the standards and build the technology according to reliability, availability, etc. We are following the Senelec standards, which is most of the European market. Our sensor is what we call a very sophisticated microphone. The differences between our technology and any conventional technologies, like either track circuits, induction circuits, axle countings, also fiber optic solutions or distributed acoustic sensors, DAS, is that our system and our sensor is completely passive. We do only listen to what's happening on the tracks. One of the purpose and the design of the system is that we want to have one and the same sensor detecting various types of what we call events and incidents. So you do not need to have one system for potentially detecting broken rail. You do not need to have one system for flat wheel detection. You do not need any rolling stock or high visual inspection trains to even check the conditions of the rail. It's a little bit, the sky is the limit to what we can detect by the sensor. The technology is, of course, patented, focusing on the areas where we are now strongest and where we actually have activities, such as the EU, Australia, India, South Africa, and Northern America. The system works basically on plug and play. We have 4 sensors that we attached at any installation point. 2 sensors on each rail to have redundancy on the rail, and covering both rails to have redundancy on the track. We only need 1 sensor for the system to operate. The main assembly, which holds the software and the algorithms, are also built on redundancy of 2 out of 3 when it comes to software. The system works in the way that when something is happening, for instance, a broken rail, not necessarily a full rail separation, that is detected, and the alarm signal or the information is sent either to the control central, to the operational central, to the maintainer, and directly on board the train, if the clients and the train operators would like to have that information. Very, very simple 5 steps. Something is happening. Then the sensor detects this and go through the library, which we call it, our basically full storage of various types of events which we have gathered over the years. And based on the client's request, the information is then sent to their locations, and subsequently the train operations are either stopped as such, or the train drivers can get information that they can drive with caution if there is just a minor incident. Any installation is made every 10 kilometers. That means that if you have an installation where you are physically sitting now, then that installation will cover 5 kilometers in both directions. And then it overlaps on the next by the next sensors. We say 10 kilometers because we guarantee 5. Our test and measuring measures far longer than that, but we want to be accurate in terms of where we identify the incident that has happened, because we send out the coordinates specific to plus minus 50 meters from the sensor on the incident of the infrastructure itself. Smart database is what we build. One part is the technology and the software and the data from NGRT, and we link that with some very simple and minor information from the client, such as information about their infrastructure and also information about their train operations. The system can also be used for level crossing operations, because we can also predict and detect specifically and exactly when any type of rolling stock will be at a certain location, which means that level crossings today operated either by track circuits, axle counters, or any fixed installations down the line, you can now have a level crossing operated on exactly the same warning and operational time of the lights and the barrier, independently of the speed of the train. As we saw in the video, it is a bit strange to see that in 2022 you still have what they call a flagman, a lookout to watch for rolling stock when maintenance is going on onto the track. You can use this technology by basically having a small briefcase. You click the sensors on, and then you press one button, and then you have a prediction of everything that's happening onto the track by any type of rolling stock. knowing that the vibrations that we detect travels in the rail with 6,000 meters per second, you can also use this technology even on tracks where you have higher speed than the regular regional 160 or 200 kilometers an hour. We provide our own graphic user interface designed upon the client's request. What you see now on the screen is an actual train detection, where it says up in the right-hand corner what is happening. Here it shows that a train is approaching, and that is the first level of information that the client requests. Then in the center of the screen, you have a more detailed information about what is going on that specific location. When the train now then has traversed and departing, you will also see that. On this GUI, the client can go into any areas of the screen by interactive buttons, and they can go further into the depth to see what has happening and what was actually going on an incident. As I said, this is a generic GUI, and it can be designed and built and colored and placed in any kind of shape and form the client would like to have. We do trackside processing, which means that everything is happening at the location of the incident. Taking broken rail for as an example, we do not only detect a full rail separation, we also detect cracks, visual or non-visual, down to 20 millimeters. So that when a crack and a rail starts to crack and it comes to 20 millimeters or more, then that will be identified and reported to the maintainers, for instance, who can then plan by saying, okay, we do now have a broken rail incident in progress, and we need to put that into our maintenance scheme. It is important to remember that we do not need any rolling stock to detect any crack or broken rail, because as you will see now, this is an actual broken rail detection that happened actually when a train was passing. But you see on the lower part of the screen, that is what we call the background sound. This is the stress which is in the rail by default when it is laid down. And you will now see there on the top screen a sudden rise. And this is actually a train who has caused a broken rail while the train is passing at a location. And if you have your sound on your devices, you should be able to actually hear now the train passing, the sensors. And if you heard closely onto this sound, you could actually also hear that this particular train had a flat wheel. So we are also able to detect flat wheels and flat spots, identifying exactly the bogie, the wheel set, and the wheel itself if it is on the right or the left-hand side, going into the train's driving direction. This is example of a cracking rail. This is taken from one of our installations in Spain, where the rail started to crack because of weather conditions. And this is typically what our engineers then will see when they go into the system's information detail and the database. This is another example of how the system can report depending on what the client would like to have. And if we take this a little bit fast forward, this is now a train also arriving towards an installation. And on the right-hand side, you will see detailed information. Fast forwarding a little bit more, you will now see that how the train actually operates. And if we go further, let's say here, and we can stop the video, you will now have detailed information about the rolling stock. You will see that there were no flat wheel output, so no flat wheel detected. And also, this train did not cause any broken rail incident in the 10-kilometer spectrum. With Deutsche Bahn in Germany, we were asked, okay, can you also give us exact distance between two trains? Because as I said initially, they would like to decrease the distances between two trains, meaning putting more operations on the same infrastructure. And the answer to that is yes. We can give exact prediction about the speed, the distances, and distance in both distance and in minutes between two trains. And we can do that with safety. As I said, we can count axles, we can detect flat wheels. All of this is incorporated and taken out straight from the system's software. This video is, or this slide, has some various impacts. And the interesting point here is the differences of the impacts, which we call fingerprints. It is like a fingerprint. Each incident has various type of signature. The first one was a person just dropping ballast onto the rail head. This one is the same person using his hand, tapping on the rail, the same as you knock on your door. And if we fast forward a little bit, you will actually be able to hear a person walking on the ballast, not on the rail itself, but just walking on the ballast on the outside of the track. So that means that the sensitivity is very, very high, which also means that various types of the incidents, which I mentioned previously, can be detected with one and the same solution. There are obviously other companies who are in this market. But NGRT is the only company who can actually do all of these detections with one and the same technology. This is just some pictures shown from our installations. This is a train station close here to our offices in Malaga, in the south of Spain. And as you can see on the sketch on the right bottom side, this is the layout where maybe a little bit difficult to see, but the red indicators are the sensors, the VDUs as we call them, placed onto the rail 10 meters apart. And that's what we use in terms of detection of the trains and the conditions of the train. And then it goes straight into the main assembly, which in this case we have placed inside an existing control hut. The cabinet is not big, so it can fit in any places. And these are the 8 sensors that we have on those double track location. The next location is what we called in the middle of nowhere, a farmer's field, a track that is single. And the same here again. We have 4 sensors straight into the cabinet. In this location, we have also installed our own battery backup and UPS, because the power supply from ADIF, the Spanish infrastructure managers, is not stable enough. So we have protected the system by having that. I did not mention how we send our signals and messages. Basically, we can use anything from GSM, GSMR, 2 to 5G, Ethernet, satellite, fiber optics. That for us is just a highway of information sent. The system draws about 15 watt, so 1 amp in full operation. So this is actually everything that you can see on the track, the small sensor. I do have some other videos as well, but I think, Lutz, maybe we are running out of time. This is just some images to show how we have gathered our huge library. We have now approximately around maybe 1 million different sound impacts, and this is what we have gathered together with the railways.
Yeah, can you get a bit more, please? Yeah.
So I think I'm going to stop there, Lutz, because we are close to the end. Just as a final touch, excuse me, NGRT, we are diamond sponsors on next week's Rail Live in Malaga. So if anybody of you are thinking of attending that event, please stop by our stand, and we will be happy to address any questions, but also where you can see the systems in operation real time. So, Lutz?
Yeah, thank you very much, Richard. Maybe there are some links available to the video. You could send it to me afterwards. Then I will include it into the final mailing of this webinar. I've catch now 2 questions, and I have to share my screen again. The first one is how much track kilometers are already covered with the NGRT technology, and is it also planned to be used for urban application cases?
Take the last question first. Yes, this application can be used for any place we have a track, either high speed, regional speed, urban, metro lines, tram lines, what have you. As long as there is a rail and there is a rolling stock moving on that, or a rail infrastructure, that's significant. NGRT has just been selected by the world's biggest railway, the Indian Railways, with their 120,000 kilometers of track. And we are now deploying our broken rail detection in India. So currently, I would say we are covering in the thousands.
Mm-hmm. My question on the urban application case is on the sensitivity of the system, because there are much more disturbance issues that people are going on the track or on ballast and so on. How could you find if it is a serious case or not serious?
Yeah, good question. When we detect any sound or vibration, we are using filters to filter out either road traffic, bicycles, people, or anything that is kind of close to the track. Also, the vibrations that goes into the rail. One of our secrets is obviously the specific frequency band that we are using. So it's a bit like a sonar of the submarines. Mm-hmm. You are filtering out everything that you do not want.
Yeah.
The last question I see here.
Yeah.
We are attaching the rail to the sensors to the rail by glue and magnets. There is no heavy drilling. There is no heavy machinery. We can actually install one system at one location in hours. We installed the system on the double track location at the train station here in Malaga in less than 4 hours, and we did not even take possession of the track because the sensors, what we do, we just we grind and clean the rail with some over surface rust. And then we use a specific special glue. Each sensor have 3 magnets with 60 kilos of pulling power. So with the glue and the magnets, that sensor doesn't come off.
Yeah, last question for this webinar. Is event detection based only on spectra fingerprints?
No, we have 3 sensing elements inside the VDU as itself. We are, yes, using spectra fingerprints by piezo ceramics, but we also have accelerometers and a third, a little bit secret detection element.
Yeah, and I put another question in the chat because it is very short. What about the maintenance of the system?
We only require one visual inspection every year because the system has a built-in watchdog. Every 2 milliseconds, the system asks, is everything okay? Is everything okay? And if anything is happening, then you will get a notification immediately. If someone comes and cut a cable, if someone wants to do any, let's say, damage to the system, that will be instantly reported. So a visual inspection to just open the cabinet once a year to see that obviously any mice or any other rodents have not chewed off the cables.
All right. So thank you very much, Richard, for your interesting explanation and answering the questions. For sure, you will be will be providing your contact data so that the participants will have the chance to get in direct contact to you. And I ask you all to take only 2 minutes time to fill in our feedback questionnaire. Very short, only 5 or 6 questions to be answered very quickly so that we can have short feedback on the quality of the webinar and the presentations, and maybe also your future ideas for further topics. Last 2 slides from my side, from our side. Yeah, that is the link. I put it already into the chat, and I can update our information about the EEN Supply Chain Resilience Platform. Is one of the B2Match platforms. The Enterprise Road Network, together with the European Railway Clusters Initiative, has been installed months ago. We started with 57 participants, and now there are already 856 participants from 41 countries, and 226 of the participants are covering the transport sector. If you have an offer or a request, please don't be shy to set up a profile on this platform. It's also free of charge, and the link is visible into the chat. Next ERCI webinar, it's not a Wednesday, it's a Friday this time, and it's not in 2 weeks, but in 1.5 weeks, on Friday the 2nd of December, and it's on next generation of freight and passenger wagons connection systems. Has something to do with a digital automatic coupler, very interesting technology, very promising technology to improve the efficiency of railway operation. The registration is already open, and the link is in the chat. And if you have further ideas for topics, please let us know by using our short feedback questionnaire. And that is all for today. For sure, we have 8 minutes delay. It's not unusual to have this when arriving by Deutsche Bahn. And but we have heard about technologies in order to minimize the delay on track, and I guess that technologies for condition-based monitoring and maintenance will have a huge contribution on that goal. Thank you very much for your attendance. You will get a mail summarizing this webinar. I'm asking the 2 presenters and 3 presenters to set out a PDF version of their presentation to be distributed to all of you. Thank you very much, and have a nice time, and see you maybe on Friday, 2nd of December. Thank you very much. Bye-bye.
Thank you. Bye-bye.